Sorry. Okay, yesterday we saw connections. We saw the introduction of connection, and I explained about the different types of connections or the basic types which are there in the Tekla structures. So today we will look more on the practical side of that. So yesterday, like it was a theory part, so we just had a brief introduction about the connections. Now we'll see the practical part of that connection. So we'll just see what all things are included and how the user interface of that using that in a while. So I will just open the connection. We'll start with a simple connection first. This is shear plate simple connection. Very simple connection. We'll start with that. I'll just double click here. To start applying the connection, you have to click here in this panel. You have to click the connection and then you have to apply here. Okay. Now, when I click here you can see there is a message here, pick main part. So Tekla will ask me to pick main part, primary part. So in this case, we have to just in model, we have to identify which is the main part and which is the secondary part. So in this case, column is the main part. So I will select column and then select the beam. So now you just saw that once I pick primary part and secondary part, you see this connection is applied because that condition is satisfied. So once this connection's condition is satisfied, the connection will be applied. Okay. And it will ask me for selecting again main part. If you don't want to use this connection further, you can add, go on adding connections from here. Okay. It will still remain open. That connection is still open, so we will go on applying connections like this. Okay. You can go on and on, right? So that's the way we are going to apply the connection. Now, this is application part. Like you saw how we are going to apply. You have to select the part, primary part, and then secondary part. That is the way we are going to apply a connection. And we'll see some details about it. Okay, so once we have applied the connections, now we'll go in depth to understand more detail. So I will just double click on this connection here. Double click from your mouse and you will see pop-up window is there now on my screen. So this is a pop-up window of share plate simple 146. So you can see this is a connection window or connection dialog box. Where is that? This one, share plate simple. So in this dialog box, you can see there are different tabs. These are tabs. Okay, different tabs are there. So I can click on that tab and I can switch over to whatever I want to modify or whichever content I have to modify. Like I have to go in bold, just click on the bold and you will be seeing all the bold details. If I go in plate, then you will see all the plate details are there here. Okay. Then when I go in the picture, you will see the picture part of that. So some explanation will be given on the picture, like some dimensions, framing conditions is there, different kind of framing conditions. Okay, sloping condition is there. So you can choose what you want according to your condition. So beam condition in the model. Normally we'll keep this as default. Now, when I click here, you'll see there is a symbol here, like this arrow. One arrow is like this, one arrow is like this. So this is called a default. Default. A is also a default, and this is what we will say that preset. Okay, or customize. So if you want to custom settings, so we can use this custom settings, or we can keep it as a default setting. So let Tekla decide which setting he has to use. So according to the framing condition, when it is default, Tekla will decide that he needs like this cut or he needs this way, cut this way. Okay. So when I say default, Tekla will take any of this automatically. Okay. Based on the framing condition. So Tekla will decide which one he has to take. Okay. So this is when, so if you want to apply any one of this, you don't know the framing condition, then keep it default. Okay. So let Tekla decide according to the framing condition. So here also there are some conditions is there. Like some dimension is given here. Now, because different, there are different conditions. Like this is parallel dimension. It is parallel to this beam, and this dimension is parallel to this beam. Okay, this primary beam. This clearance is parallel to secondary beam. Okay, so different conditions are there. Now, this clearance is for the web clearance, and this clearance is for the edge distance, plate edge. Okay. So different conditions are there. So we have to we can change according to different conditions from these tabs. Okay. Normally we'll keep it as default. Default. If you don't understand means what we have to keep, just keep it default. No need to worry about the conditions right now. So right now, when you are applying as a in the training session or applying as a test model or a training model, you can just keep this as default, everything as default, and um, main thing where we have to enter is thickness of this plate. So this is very important, thickness of the plate. So for example, I will enter here 12 thick plate. So this is like a thickness, so thickness of the plate. This is the connection. This is the top view of that connection. And the 3D view. Now, I can see the plate from here. It is visible. Now, We had learned something about the rendering. Okay, rendering method like um, here, this one. I explained earlier, like if you want to keep a wireframe, then control 1 is the shortcut, control 2, control 3, and control 4, and control 5. So these are the 5 shortcuts for shading. The shading option, when you say control 1, 2, 3, 4, 5. Okay, we will normally keep it as 4 rendered. Hmm. Similarly, you can see here connection is also there. So for connection, uh, for main part, we are using part shade control plus 1. Hmm. Similarly, for connection, we have to use shift plus 1. So now I will show you how it works in the model. Shift 1. So I will press shift 1. You see the component is changing now. Shift 2, 3, 4, and 5. Okay, now we'll keep it as 4. Right? So this is how the rendering works. And now thickness is there. I have added the thickness. Now I will add the position number. Now the thickness you have entered, it will be visible to you in this connection. You can measure that thickness from here. You can zoom here in the model. You can zoom and now I can measure it from here. Edit. I can see the plate now and measure horizontal. Now here, what I have done is I have kept control 1 here and shift 4. Okay. So that's why I'm seeing just the connections and parts are like wireframe and connection is rendered. So you will be able to see the connection content clearly. Okay. So I'll measure from here to here. For thickness, so thickness is now, that is default, that is 10 mm. Default is there because I have just entered here. I have not modified it. Hmm. So once I modify it, then this will get updated. Now this is default. Default means if you are not entering anything, so by default Tekla will take some standard distance. Okay. So 10 mm is a standard distance taken by Tekla. Okay. Now I will modify this connection. And here below there will be a modify button will be there. So I will just click on that, modify. And now you will see that thickness will get updated. Let's click on the modify. Click on modify and now you will see the thickness is updated here. From 10 mm, now it will be 12 mm. Now it is updated, right? Hope this is clear now. For thickness, we have to change it from here. Now there is
Yes, yes.
few more properties are there. Few more properties are there here, like part position, material grade. Yeah. So I will just show you how we are going to add that property here and how you're going to verify it in the model. So in the model also you have to verify that what we are entering here, it is getting updated there. So we need to verify also parallelly. So whenever we are uh, creating any connection, you should always verify it in the model, right? So here I will add plate prefix as P, number is 1. Position is the part position and this is number. Now numbering system, I will just explain you. I will show you this chart. you might be already aware of this numbering system. Like for main part, we are using B, assembly prefix as B, and then for plate, normally we'll be using P for plates. So there are two different prefix which we are using in Tekla. One is assembly prefix, as seeing on the left side, and on the right side is part prefix. So this is for the main assemblies. These are the main assemblies: column, beam, girder, HVAC, brace, plus stair, handrail, ladder, loose plate. So these are the main assemblies. Okay, main assembly will be your assembly drawings will be having this prefix. Okay. Prefix means this is the assembly mark, you can say, but this is not a complete mark because this is just a prefix. Mark will be like B1. So when you add one here, it will be a mark. We call it as a mark, assembly mark. So, now, now when I add, say when I add B here, it will be a prefix. And when I'm adding one, so it will be called as a mark. So in this is a prefix, and this is called as prefix. Okay, this part will be called as prefix on the left hand side, and on the right hand side will be called as series. Series or serial number. Um, series. Normally, we in Tekla will call it as series. So prefix and series combination. So this complete set will be called as a mark. We'll call this as a mark. So above is the example of assembly mark. Assembly mark. Okay, so this is the assembly mark. And similar to why this is assembly mark? Because this letter is capital, and you will see in the exam this thing, this table. It is showing assembly mark are capital. Normally they are capital, and the part prefix will be small. Why because it is like a, fabrication concept or fabrication concept. Like for the main assembly, we are using capital letter. Okay, and the small connected parts which are welded to the beam, their letter will be small. So if the plate is connecting to B1, so it will be like P1. Okay. If any plate is connecting to a beam, can be called as a. So this is also same prefix, similar kind of thing. Okay, similar thing. This is like a similar thing, but the use is different for both. Now this one we called it as uh, part. Okay, it is part. So this is combination. You can say combination of uh, alphabet and number, numerical. So this is the final output, and this is like a guideline. This is basic guideline which we are following, and you will see numbering is also given here. Series 1, 101, 10, 1,001. Right? So these are the series which we are using generally, right? And it will look like this. The final product will look like this. And when you're looking at some drawing, if you're looking at some drawing, the drawing will be like this is the beam, and I will have a plate here. The plate is here. Then some plate is connecting here like this. One plate is here. Just example. Now this plate we will call it as uh, P1. This is 2. This one, and this will be P3, and this will be your main part. So this is P1. So there will be a small name for this also, like B1 for this separate assembly, like separate part. If we extract a separate part of this, then this will be called as small B1. So when you see a small piece of this is P1. Okay. This is P2, and this is your P3. And when I separate this, now this is a complete assembly drawing. What you are seeing here, this is a complete assembly drawing. Yeah, there are some few more things in this, like dimension will be also there. Now here I am just explaining you the marking system. So we will not go into the dimensioning part. The dimensions are also there, but right now we will not go into dimension. So I will just explain you how the marking system is there. This is like a marking system in assembly drawing. Oh, I think you are already aware of this part. So this separately will be P1, P2, P3 separate. When you separate these out, it will be P1, P2, P3. And when you separate this piece, this will also be B1. When I separate out this like this will be a small B1. So here when I add, this will be small B1. Separate piece. But when they are in this assembly, we call it as B1. So this is the assembly mark. So this is common for all. So this is also B1. So actually when I provide a mark here. So assembly mark for this P1 is also B1 and part mark is P1. So this way we understand that this P1 is part of B1. Okay, is actually a part of B1 because it is going to be welded here, right? So like we are having the family name system, family name and your name. So your name will be a smaller name and your family name will be recognized by your family name, surname. You're having that concept, right? So similarly, this is like a family name, father name, you can see, and this is a child name. Children objects, these are the children objects of this father. Okay. So something like that. Okay. So now you can understand that this system, how this system works, numbering system. So
Yes.
this explains the numbering system in Tekla, how we are using the numbering system in Tekla, right?
Okay.
Similarly, here I have given that P smart. Okay? P is a smaller one and one is the series. And then we are using the material grade here. Material grade is a steel grade of steel. So grade of steel will be listed here in your catalog. So when I click here, you will be getting the catalog names. And Tekla will ask you to select the material for here. These are the available materials for different items. So steel, concrete, all those things will be there included here. We have to go for steel. When we are using steel, we have to go for the steel item. So in steel item, you will see this n number of grades will be there in this. We have to choose it from here. Now these grades will be different for different environment. So this is according to the environment, right? Whatever environment we are choosing at the start of when you're starting the Tekla, at that time it will ask you for environment, right? Indian environment, UK, US. So these grades will be according to that environment. Okay. So whichever environment you are choosing, say you are choosing US environment. So you will get the grades of that particular US environment. Okay. Now here we are having UK environment. So UK environment grades are visible to you here. Right. So UK grades normally this grade will be given in your design drawing. This is like a sample design drawing which we are using. And if you want to see the grades, you have to go in the notes part. In general notes, you will be having the grade for the listed grade will be listed down there. Now here for our training session, I have added all the grades, UK, US, and India standard. Different grades I have added. These are just for example. The actual grade might differ from this thing. So when you are presenting in the actual design drawing, this might be different. Some different grades will be there. But generally, we are using US standard A992. We are using this. UK, most of the case will be using S355. And Indian
Hmm.
environment, we are using IS 2062 grade A. Now, here sometimes we are using E350. E350 will be there. So the grade might change in the case of Indian environment. So this will be E350 and for plate it will be E250 grade. So there is a small change in the Indian environment. So these grades are not here right now. But for Indian we'll be using E350 or E250 for plates. So miscellaneous steel means plates, handle ladders, all those will be having different grades. So normally miscellaneous steel means the handle ladders, those that steel will be having the low carbon steel and this main steel will be having a lesser, okay, or the high strength steel. So here you will find higher grades. Okay, so this density is high. Okay, and this is a low grade steel for miscellaneous item like ladder, handrail. All those steels will be having the low grade steel. Okay, cast iron. Okay, normally. And similar thing for the bolt also here. You can see bolt is also different grades are there. High strength, normally high strength and low strength. So low grade bolt will be A307. High strength will be A325 for US standard. And normally for other like UK and Indian standard, you'll be having 8.8 grade. In UK standard 8.8 XOX we are using, and in for low grade we are using 4.6 XOX for bolt. Right? Now, similarly, here we will find the UK grades are there listed here. So S355, S355 is what we are going to take now, right? S355. This is a higher grade. I will say apply. Okay, now it is listed here in the materials, and I can give a naming for this material also. So naming I will give it here as plate, and then I will say modify. I will modify that connection, and now I want to verify. Now, important part is to verify if that those uh, these variables or these different uh, combinations which we have given, those are applied to the connections. So you have to verify it. So before that, before verifying, I'll just go to bold. I'll just go to bold, like here in the bold. Also, there are bold grade standards will be there according to the environment. Okay, this is also according to the environment. So whichever environment you are choosing, you will get those grades according to the environment, right? So now here UK standard grades are there. So I will just select 20, tolerance 2 mm, gradient material, yes. Side shop. So this one will be side. So most of the case, bolt will be side bolted in most of the time. And if there is a plate, it will be shop welded. So our connections will be, most of the case, it will be. So whatever connections we are using, so it will be shop welded and side bolted connections. Okay, so this is the terminology we are using generally for all the projects typically. Okay, shop welded.
Side bolt.
Yeah. Shop welded and side bolted. So normally most of the case we are using this terminology, but some case there might be a change like you will be having a side bolted connection. So something which is not possible to be welded on site. Some problems will be there to weld certain assemblies on site. So in that case, you will be having a side bolted connection. Okay. So everything will be bolted on site directly. So there will be no welding connection. Maybe welding is not allowed in some cases. So we'll be having a side bolted connection. Okay, so here we have to choose that side bolt side. So you have to always you have to pick right thing. Okay, as I'm showing you on the screen. So always you have to pick and verify all this, whatever you have chosen is correct or not. Okay. Then next is your spacing, bold spacing. Now it is having a default. Now you don't have any values here. So Tekla has taken the default values. So automatically you are seeing that the quantity and number of bolt, everything is already there automatically. So this is like default values, right? So according to the depth of this beam, it is taken 1, 2, 3, 4, 5. 5 bolts Tekla has taken by default. So it has some internal calculations will be there for Tekla for calculating the number of bolt. So it has taken 5 bolts by default, and spacing is also there. So it has also taken the default spacing of bolt. So because we have not added here anything, so it has taken the default. And also there are 2 rows, 2 columns of bolt. So sorry. These are called columns, and this is called row. Okay. Whenever we are doing any connections, shear connections, that time in engineering language, we will normally say this vertical line as the column and the horizontal line as the row, right? So here this is for the number of columns, and this is for the number of rows of bolt, right? So now here we are seeing there are 2 number of columns. So I don't need 2, I need 1. So I will just go there and say 1. I add their quantity. I will add their quantity and then just say modify. So now you will see the connection is updated as per my
Yes, sir. Agree.
as per my modifications or as per